In today's lecture, so let's discuss how to predict the output based on the transfer function model. The transfer function is given by a yt is equal to the z power of negative d represents the time delay. So there will be d time step time delay, b ut. So a and b are polynomials with degree n. So first, let's expand the input and the output using the polynomials in a and b. We know the z power of -1, it represents the time delay. Then we have, on the left-hand side, we have yt. So we have yt plus, so this is the first term, then a1 yt minus 1 until an yt minus n. At the right-hand side, because of time delay, so the first term will be b0 ut minus d. The second term at the right-hand side will be b1 ut minus d due to the time delay. Then z negative power -1 will be -1. So until bn ut minus d minus n because of power of z negative n. Then to predict yt plus 1. So let's assume here, so time delay d, so the d is at least greater or equal to 1. So in other words, there will be at least one time delay. Then let's try to first predict, so yt plus 1. So the current time is t. Okay, so yt plus 1. So yt plus 1 based on the current time t. So based on this equation, so we know, so the yt plus 1. So in this equation here, so in the equation here, so we just need to change all the t to t plus 1. So all the t to t plus 1. Then we have yt plus 1. Then we have the prediction. So yt plus 1. So conditional time t will be so negative. So a1. So if you change t to t plus 1, so here will be yt. So it will be yt. So understand like the yt, it is a past information. Okay. So at time t, we have the output measurement yt. Okay, and so on to be negative. So we move all the y terms to the right-hand side. So we have yn, change t to t plus 1. We have an yt plus 1 minus n. Then the right-hand side, we have all the past control input. So it would be b0, so ut plus 1 minus d, then plus b1 ut plus 1 minus d minus 1 will be minus d. So until the last term will be, so bn ut minus d minus n plus 1. Okay, So this is the formula. This is the formula we are going to use to predict yt plus 1. So based on the current time, we have all the past information. So the past inputs from ut plus 1 minus d minus n until ut plus 1 minus d, and all the past outputs from yt to yt plus 1 minus n. Then let's do one more. Okay. So this time let's do to predict yt plus 2. Okay. Say now we want to predict yt plus 2. Okay. So to predict yt plus 2 again, so based on this equation, we change all the t, so all the t to t plus 2. Okay, all the t to t plus 2. So therefore we have the first negative a1, then yt, if we change to t plus 2, here we have yt plus 1. The yt plus 1 is the future information. Okay, so therefore we write here will be yt plus 1 conditioned on t. Okay, then all the other terms, okay, we just change this 1 to 2. Okay, then depends on the time delay. Okay, depends on the time delay. So the ut plus 2 minus d. And it could be a past input or the future input. Then we can use our notation for like the height. Okay, the height, the u height. Okay, it depends on the value of d. Okay, it could be a future input or past input. Then we change all this t plus 2. Sorry, so here will be so t plus 1. Okay, so we have already added to 1. So here will be t plus 1 minus 2. Again, we use the notation height. Use notation height. Here will be 2. So this is formula we are going to use to predict yt plus 2. You can see from here, so to predict yt plus 2, we need both the future output and the past output. We may use the future inputs and the past inputs as well. Then now let's consider the general case. Okay, so the general case, okay, so the predict, so the current time t to predict yt plus k. Okay, then therefore we know, so we need to use, okay, so here will be equal to negative a1, which in t to t plus k. So this could be, depending on the value of k, could be past information or future information. This I'll use the notation height. Okay, here use height. Okay, then the an, so y height t plus k. So here will be, so the negative, negative. Okay, then here again, so it's plus, here we plus. We put height, so t will be t plus k, the t plus k, then height t plus k. Okay, so this is the general formula, so we are going to use to predict the future output at k times steps ahead. So therefore, we have the general formula. So the output y t plus k, so based on the current time t, will be negative for j from 1 to n. So a1 to an. So the first term will be when j will be, so you can see, so when the j is 1, when the j is 1, we have t plus k minus 1. Okay? Then, so this one, the subscript 1 will be always the same with this minus, so 1 minus 1, n minus n. So we have aj to minus j. And this j is from 1 to n. Okay, so the first sum will be negative sum. So j from 1 to n, so aj. So y hat t plus k minus j. So for the second term, it starts with 0. Okay, we have b0 to bn. So j will be from 0 to n. So then, so when the j is 0, so we have the b0, then here will be tk plus d minus j. Then the subscript j and the argument of u, the sum of the two will be t plus k minus d. So here's the 0. The sum of the two will be t plus k minus d. So 1 will be t plus k minus d minus 1. The sum of them, the sum of the 1 and t plus k minus d minus 1 will be t plus k minus d. The last one will be bn, so t plus k minus d minus n. Then I can also write this in a compiled form, okay? So let's change all the y's, okay, to the left-hand side, okay? But change all the y's to the left-hand side. So we have equal here will be plus, plus, and plus. Then if we use a polynomial, so if you see, so the left-hand side can be written as, so a z, so y at t plus k. So the right-hand side can be written as, so bz u at, so t plus k minus d. Okay, so therefore, we have the predictor in a compiled form. So it will be just a y hat t plus k. Then if we use a time delay, so be the, so remove this one. So remove this one, so we have the z power of negative d to be this equation. So z power of negative d, so b and u t plus k. If we compare to the model, okay, we just change the y, the yt to height yt plus k and ut to height ut plus k. The prediction yt plus k condition t depends on some other predicted output. So for example, for the yt plus 2 depend on the prediction of yt plus 1 condition on t. It is possible to find an expression for yt plus k condition on t, which depends on only the measured outputs, the past output, and the actual past input, and the predicted future inputs. So this saves on computation, which is particularly important in application to adaptive control. So while the predictors, so as well as the predictions themselves, have to be computed online. It also gave us some insight into the way the predictor design affects the predict controller.